So good morning all. So today's first session is the build tools. So we will use Maven as a build tools. So there are many other build tools, but Maven will give you a high level concept like how and where we can use the build tools and what are the advantages of the build tool. Okay. So if we go by a definition, then build tool is nothing but a set of programs that automate the creation of your application compilation and creating a executable out of your source code. So it could be a APK for Android, or it could be a WAR file, it could be a exe for Windows. So this whole process basically includes compiling, linking, packaging of your code into a executable form. So now these days, it also includes downloading the dependencies, compiling source code into binary code, packaging that binary code into some maybe in WAR or in APK, correct? And it also includes running tests, and in some of the cases it may also include deploying your binaries into the production or your test systems. Okay, so this is like a very high level definition. So let's go back some time back when we used to compile our code. Maybe let's take an example when we started learning coding. That time what we used to write, for example, in case of Java, we will put up all the Java files in a directory and then just do the Java C, and it's like that's that way. So adding a file, or sometimes we just miss at writing some or including some file name, and for running test or even the compilation output file used to be sometimes you just forget it, then it is just a.out file, for example, or a.exe in some cases. So, and everybody used to have a different way of compiling their code. So these build tools basically they help in automating, not only just automating, but standardizing the way we compile the codes. So if we are using a build tool, for example Maven, so whosoever is compiling, so for them the whole process of compilation, linking, or even running the test cases becomes a standard. So they don't have to worry about their build process, they have to just worry about writing the code and executing it, which is their main core aim of their activity. Okay, so why do we use build tools or build automation? So we just took one example. So in some small projects, developer will often manually invoke the build process. This is not a practical for large projects where it is very hard to keep track of what needs to be built, in what sequence, and what dependencies are there in the build process. So using a build tools allows a build process to be more consistent. Okay, so these are the advantages why we should use a build tools or build automated tools. So there are many build tools available these days. For Java there is an Ant, which has been there for a very long. Maven is there. Then you have Gradle. For .NET you have a Ant. For C Sharp you have a MS Build. So depending upon what kind of a platform or what kind of a software stack you are using, you have a different build tools available for those. Okay. Then for Maven, we will just go through these slides and at the end I will just show you some of the basic examples how to use a Maven. So what is a Maven? So Maven is a project management and comprehension tool. So this is a definition from Maven itself. So this tool that provides developers a complete build lifecycle framework. So development team can automate the project's infrastructure in almost no time, as Maven uses standard directory layout and default build cycle. So in case of a multiple development team environment, Maven can set up a way to work as a per standard in a short time. So in most of the project setups are simple as usable. Maven makes life developers easy while creating reports, checks, builds, testing, automation, setups, blah blah blah. So in short, if you say Maven is a build tool which provides you a standard way of compiling your code. So it also supports multiple features like these listed here: builds, documentation, reporting, dependencies, source code management, like no integration with the source code management. It can also support release, distribution, mailing list. So this list is a very big list, but most of the people, they generally use it for making builds, uh, doing unit testing. Some of the people, they use it for dependencies. Like most of the people, they use it for dependencies, integration with source code management to some extent if they don't have a DevOps framework, and some of the people, they also use it for reporting purpose or documentation purpose. Okay, so advantage of Maven is, like, it simplifies and standardizes the project build process. It can handle compilation, distribution, documentation, team collaboration, and other tasks seamlessly. So these are just a definition. Okay, so there are certain features of a Maven. So these features, they are also, like, similar to other build tools. Some definition might change, or some of the delta might also exist in some cases. So first is simple project setup that follows the best practices. So Maven also gives you a project structure, like how your project should look like, where your source files should be there, what should be the, overall structure of your source code files, then where your binaries would be generated, where your unit test reports would be generated. So all those uh, folder structure is also generated when we create a Maven project. So since this is a build tool, and it remains consistent across all the projects, so if somebody knows how to compile or how to basically run a unit test cases and do other stuffs, then it is easy for that person to work on any other project using a same build tool, or even other build tools will be similar experience, just some of the commands will change. Then Maven also helps in projects where you have a very large, or you are adding more and more external libraries to your repository. So in Maven, what happens, like in the end we will see how it manages the external libraries, but just to give a brief, generally what used to happen earlier, like if we are using a Java program, and if we need a, for example, JSON parser, so in that case what we will do, we will go to internet, search a particular Java version, see its compatibility with our current Java and other components, and we copy it into the lib folders. So as we add more dependencies, our library folders becomes very large and difficult to manage. And if any of the dependency changes, then you have to just basically download the other dependencies libraries, because these dependent libraries, external libraries, also have a dependencies or other dependent libraries. So it becomes very huge and nightmare to manage these libraries, and also to keep on pushing them to the repository. Okay, so but with Maven, this whole external library management has become a very easy. So we will see it, how it works. Then you have an extensible and ability to write plugins So in some cases, like if needed, you can also write a plugins for Maven, similar to, like you can write it for Eclipse, but generally it is not needed. So you already get some um, plugins ready-made. For example, if you want to integrate with the Sonar Cube, which is a which is a static code analysis tool, or if you want to integrate it with the GitLab, so you already get those predefined plugins. But if somebody wants to write their own plugins, it is also possible. So uh, so it has a model-based builds. We will see what does it mean, but you can build any number of projects in a predefined outputs. So basically, it gives you a template in a object model or XML based configuration file, which we call POM file. So you just define template there, and your outputs will be generated in jar, var, or meta files. So what else? Documentation, like you can generate documentation using a Maven. Uh, but these are not very much useful. So what is relevant to us, we will just see. So then this release management and distribution publication. So with Maven, we can integrate our source code management, for example, CVS, GitLab, GitHub, and do the release management. So basically, you can just pull a code from it, compile it, and generate a var. So everything can be done using Maven only. Okay. Then it is backward compatible. So Maven 3 is compatible with Maven 2 and so on. So then it also allows you a parallel build. So if you know, if you have been in software industry for 10-15 years, then you would know, be aware, like earlier builds used to take a long time. If you have not um, what you can say, customize, or you have not tuned your build in tools earlier, so everything used to be a sequential. So one module compiles and second and third and but with Maven, you can also do a parallel builds, which increases your time, and basically improves your performance. So it has a better error and integration reporting. So if something goes wrong, build is not maybe it is not compiling, or even if you have some integration with your Sonar or maybe SCM code repository, in that case it will give you a full description of error, which you can use to resolve the issues. Okay. So Maven, for running a Maven, just JDK 1.7 or above is needed. So there is no memory or disk or operating system limitation. So depending upon what type of project you have and how big your project, so that those things will dictate your memory and disk space usage. Maven is available for, like any of the operating systems. So it's basically operating system agnostic. So there are some steps which I will just show you. So let's show it now. Okay. So this is the, like home page of a Maven. So you can download
I have one doubt.
Yes.
Yeah, I wanted to ask that does Maven has this capability to schedule? Is there any option to schedule the builds, or that is done by Jenkins?
I'm not sure about Maven, because I don't think it has a cron job kind of a functionality. So if you want that kind of a functionality, then you can use a cron job, or you can just go with tools like Jenkins or similar kind of a tools.
Yeah,
But
okay.
it is just a build tool, it can only help you to get the code, or in some cases like or otherwise it is mainly for compilation and generating the artifacts. Okay.
And documentation means that generating reports of what all areas got failed and what time it ran and how many were successful. Is that what documentation means?
That also could be, or otherwise it also helps you to integrate Doxygen kind of a tools with Maven. So you can also generate a Doxygen tool. So that is true, whatever you are saying. So that is also one aspect. So other aspect is also like you can also integrate Doxygen kind of a tools with Maven.
Yeah. Okay.
So these are the different types of installations available. So basically it is just Java files with which you can just unzip and run it. So it will run on a JVM. So that's why it is a operating system agnostic. So I have downloaded.
One more question I had, just one question that came up. It's here you mentioned that Java Home is required, so that is for the running of the Maven tool, right?
JVM is needed.
Yeah,
Java
JVM.
virtual machine.
So if my code is written in a higher version of Java, then would it compile in the higher
No, I'm
version?
just talking about the Maven. So how to run a Maven? So Maven, for running a Maven, you need a JVM. For running your code, you need corresponding Java. So on a machine, you can have two Java versions also. So if you are going with the Jenkins, when we go to the higher sessions in Java, then you will see you need some specific version of Java for running your tools. But inside the Jenkins job, you can run your basically you can compile or run your code with a different Java versions also. So that could be Java 11.
That is possible in Maven also?
No, because Maven and your code would use the same Java until unless you explicitly provide Java directory or Java installation directory to your code.
Okay.
Okay.
Yeah.
So let me just extract it. So this is how it looks like. So then next step is so Java home, if it is already set, you can do it, or otherwise the main thing is you have to set your Maven home, correct, and you can always set it into your environment variable as a Maven OPTs, or you can just set up M2 home to your path directory. Okay. So for simplicity, what we can do, we will just run it from here. You can just move it and do it, but for okay. So if we just run it, you can run it in this way. Okay. So
your screen is not visible. Your screen, only the PPT is visible.
Okay. So sorry, my mistake. Okay, so let me just what steps I did, I will just explain now. Okay, so I just downloaded it using the wget command. Okay, and I just copied this path from the Maven home. Okay, and then I extracted this using tar command. Okay, and then
might be Anil, you can increase the font.
Okay. Let me see.
Control scroll is not working.
Is it better now?
Yes.
Okay, so if we see inside the bin folder, we have a Maven command which you can execute. So for making it available to like everyone, we can just link it to the user bin, or we can just set a Maven home path. Okay, so we will see it later, but this is how you can configure it. Okay, so then we have a POM file. Basically, POM file is nothing but a project object model. So it is nothing but it's a kind of a template which tells what all. Well, basically, you can just say it is a configuration of your Maven build tool. So I will just get you one example. Simple example would be better. I just have a so this is a very simple hello world example. So if I just show you Java Maven, okay. So here we have a pom.xml. So this is a very simple, simplistic Maven project object model of POM file which we call. So here if we see, so we have some sections which tells what is the what would be the output format, or if something is generated, how it would look like. So so it would generate a jar file which would have a group ID as a com.example, and its artifact IDs would be this one, and it has a version. So basically Maven also helps in generating a versioned document or versioned artifacts also. So for example, today you are working with a 2.0 snapshot, or maybe tomorrow you will generate a 2.1 snapshot. So you can just change a version, and it will also can be used for versioning of your generated artifacts. Okay, so if we just go and see it, then there is a section for the dependencies. So this section tells Maven to download these dependencies from the Maven repository, okay, whenever the compilation is happening. So okay, let me just come back to this topic. So basically there is a dependency sections which tells which these are the external dependencies in the projects which can be downloaded at a runtime, or like during the compilation time. So you don't need to check in any of the dependencies or any of the libraries as a part of your project itself. Okay, then we have a build rules which tells like how to compile it, what are the different compilation plugins. So in this case, like we are using a Maven compiler plugin for compiling the this particular example. And then there is also a plugin for generating the surefire. These are the basically test reports. So these Maven can also be used for generating your test reports using these plugins. Then you can also define goals. So goals is nothing but like these are the arguments to Maven, which will tell Maven that what to do, either to generate binaries, to run the test, to what you can say, to deploy it to the third party, to some server, or do the complete lifecycle management. So we will see what are the different common goals which are generally used by the majority of the people. Okay.
Yeah,
Then
one question I had. Where does it download the dependencies from? Can we configure that location from where, or
yes, we can configure it. I will just show you how we can do it. and what are the use cases for those things. So just give me just some time. Maybe we have a slide for that one also. So there I will show you how it works
So
internally.
this, yeah, one more question. These plugins are basically jar files that are getting downloaded, right?
Yes, correct. So these are also downloaded when we run the Maven.
So basically, there is some standard format in the way in which the jar files are written, because, like, if you say that goals are there, so how does Maven know that? How does a jar file know that this particular goal has to do this? Like here.
Yeah, maybe I will just show you. Next slide is on the goals. So I will just tell you what the goals are and what they actually mean. So basically, plugins are nothing but these are the what you can say helper jar files or helper tools which Maven uses to achieve some of the functionalities which are not there as a part of default Maven installation. Okay.
So plugins
For
and
example,
dependencies are different, right? Dependencies are used by the code.
Dependencies, yeah, correct. So dependencies are the external libraries which, when you compile your code, they are used for linking your code. So I will just give you an example also, so that that will get more clear. Okay, so then these are the plugins where we are using Jacoco for generating the code coverage. So I'm just trying to show you what is the breadth of the Maven, what kind of activities it can do. Okay, so if I just go back and show you the different sections. So first section is the versioning of your artifacts. Like when you compile your source code, uh, its output would be what would be the output. For example, in this case, we are telling the char should be the output type, and it should be versioned at a 2.0 snapshot, and artifact name and group IDs. These can be the group IDs and artifacts. Then we are telling the dependencies. So these are the dependencies used by your source code when you are compiling your code. Okay, so normally what happens when we write a Java code, we use different packages. Okay, so these packages are nothing but some of the cases these are the already written libraries. For example, stdio, for example. So that is a library which your source code will use. So well, this is a very not a good example, but just to give an example, like in Java, you will just write a code system.out.println and print your string. But what is the how to print, and what is the definition of this particular system.out.println? So that is defined in some other library. So that is a maybe a println library or something else, or maybe a system out library. So those libraries, they are linked to the your source code during a compilation or linking process. So these are the external these are the libraries, basically, correct? So these libraries can be part of your Java environment, or these can be downloaded from your these may not be your standard packages. So if these are not standard packages, these have to be downloaded from somewhere. So this somewhere, I will just explain you what is this somewhere. So basically, these external libraries Maven can download uh, on the go when it is compiling the code, and then these get linked into, and whole your source code is packaged along with these libraries, and a jar file is generated. Okay, so this is how these dependencies sections basically defines that this is your dependencies group ID, this is your artifact ID, and this is your version of your library. So then you have plugins. So these plugins are used by your compiler, or maybe or we can say your Maven build tool, to compile or to execute unit test, or to generate reports, or maybe doing a code coverage kind of a thing. Okay, then what else? Then you have a goals. So we will just cover those goals in a second. Okay.
And one more question I had is, in case the dependency is not available as a standard this thing, something that can be downloaded from a public URL, then how do we does Maven has a facility where we can specify a jar file within our code, or how does it happen?
Just give me a second. I will cover that topic also.
Yeah. Okay.
So so as we were just discussing, so this is like high level text based definition of a POM file. So this is like which I was just saying, you have a group ID, artifact ID, and version. So using group ID, artifact, and version, you can identify any of your Maven generated artifacts. So it can be external library, or it could be your own artifacts. So if I just tell you, just give you an example. So for example, let's take this example. Okay, so not this one. So let me just give you an example of okay, just give me a second. Okay, so I will just show you how the Maven repository looks like. Okay, so Maven has a repository, so you don't have to think from where you have to download the artifacts or external libraries. So Maven has its own repository. So it is a internet available repository. Okay, just give me a second. Let's cover. Okay, so this is the overall architecture of your Maven. So Maven, when we say Maven, is not just a tool which runs on our site. So it's just a Maven client. Okay, so there are many other things in the system. So one is the remote repository. So all the remote repository is basically a we can say it's a library, or it's a server which contains different libraries. So all those libraries or jar files, they can be labeled, or they can be accessed using a group ID, artifact ID, and version. Okay, so these libraries or jar files, they are already there. If you want to upload you can also maybe like somebody develops its own library or jar file, they can also push it to the remote repository, and this will be available for everyone to download. Okay, so this is how your central repository is. So this is what I was just trying to show, that this is the our central repository. Okay, so for example, let's take Python 4j for example. Okay, so this is a Python for Java. So here it will get a small description which you can read and see if it is.
Your screen is again not visible. Only the PPT is visible.
Sorry. Let me share my whole screen. That is okay. So I hope now it is visible. Can you see it now?
Yes, yes.
Okay. Thank you for bringing it up. So okay, so what I was telling, in this whole architecture, we have a central repository, which is kind of a server hosted on the internet. It's not a server actually, but it is a group of server. But just for understanding, it is a remote server on the internet, which contains all the libraries which can be accessed using artifact ID and group ID and version. So each and every jar file library will have a index, or which have a master key to access a group of these three elements. Okay, then the Maven command which we were running, so it is running on a individual's machine. So it basically connects to the central repository and gets that particular library or jar file from central repository to your local machine. So in local machine also you have a local repository. So when you download a particular repository or a particular library, it is not directly used into your program. Instead, it is downloaded first to your local repository, and then Maven build tool basically uses that or picks that library from your local repository, and then it gets integrated into your source code. So this is how it works. Okay, so local is nothing but a folder on a machine. So I will just show you one example. So generally your local repository would be in your home directory. Okay, so here if I show you, so here you will have a .m2 folder. So probably we have not run a Maven repository here, Maven till now. So otherwise you will see something like, let me show you, maybe I have some repository in this local machine. Okay, so if I just show M2, okay, so here M2 is my local repository. So here in this repository I have a different artifacts which have been already been pulled into my local repository from the central repository. So these are the different packages. So let me just show one org and JUnit, for example, Checoco. Okay, so if I just show you, so this is basically plugin, not this one, CD, which one, Apache. Okay, so if I just Tomcat, okay, so these are the different libraries which I have already pulled from the central repository into my local repository. So if I just show you, so these are the Apache Tomcat libraries. So inside Apache Tomcat, so there are multiple libraries. For example, Tomcat JDBC or maybe API. So if okay, it is not downloaded yet. Okay, so probably it has just created a structure. It is not yet there, but if it was there, then you would see the .jar files here in the directory. So for example, if I just search Apache Tomcat, you will have these different libraries. For example, we were seeing the embedded core. So this particular version, so here you will see the these jar files. So as soon as you define the dependency for a Tomcat embedded core in your POM file, this particular jar file would be pulled from central repository into your local repository, and then you can use it into your project. So if you see it here we have a group ID, which is org.apache.tomcat.embed. Then it has artifact ID, which is basically the name of this particular jar file, Tomcat embedded core, and it has a version. So basically, when you have to use a particular POM file or a particular library, Maven library in your code, you have to use the combination of these three. So Maven gives you this flexibility, like you can just copy this whole dependency and paste it into your POM file, and it will get included into your code. Okay, so this is how it looks like. So you some of you had a question like, do we always need a central repository? Because in some of the cases what might happen, like your organization might not give in access to the central repository for security purposes. Okay, so in that case what you can do, you can set up your own remote repository which is inside your organization's boundary, and you can configure your Maven tool. So in Maven you have a conf file. There you can specify if you are using your local repository. So in that way, when you doing a Maven compilation or Maven install, so in that way it will pull the libraries from the remote repository instead of pulling it from the central repository. So this is the one use case. Or other use case can also be like some organizations, they set up their remote repository so that they will, so people will just pull it from the local organization's remote repository, and if needed that can be synchronized with the central repository. So the use cases can be different, but most of the organizations from the security perspective, they just set up their own local remote repository, and after reviewing the jar files and other licensing parameters, they push or they set up the jar files or libraries to the their own remote repository. So that could be the one way of using the organization's remote repository or internal repository, you can call it. Okay, so I hope this answers your question also.
Yeah. One question I had, like when we say pushing into the remote repository, so it is like creating folder structure according to group ID and then just putting
No.
the jar.
So there is a command. Basically, we call it a Maven install. So in that case, you have to install the libraries to your internal remote repository. So there are certain commands you can just. So I'm just telling you the layman terminology. So it is actually a Maven install command. If you run it, then you can push or you can just what you can say, install or insert that particular library to the this particular remote repository. So in GUI, if you say like this internet remote repository, if you want to add your repository, then you have a GUI interface to do it. But for this remote repository also, you have certain tools available, but if you want to do it using a Maven command, you can also do it.
And for installing on the central repository, is there some community that checks what code, what jar file I am uploading, or anyone can install push any jar file over there in this mvnrepository.com?
So I'm not sure, but generally, like known organizations, like they put their own information, like home page and category, those kind of things. So basically depends upon what kind of a functionality you need. So depending upon, because it might be possible like somebody might have just created their own custom implementation which might not be available, correct? So in that case, like you have to download it, but again you have to just see what is the one when it has been updated and how many downloads are there. So that gives you a kind of credibility also.
Okay.
Because open source there is very less what you can say, that control is not that tight, somebody can't be there to what you can say review and review and validate it. So maybe some of the communities, they run certain tools and checks before somebody uploads a particular library or binary, but we can't rely on those. So own judgment, own way of like looking whether is it reliable or is it from reliable source or those kind of things. I think that would be the better approach first.
Okay.
Then there are certain examples which we have used. So let me see. I could not set up this whole setup, but let's see if we can do it. So this is my
I had one question. Like you mentioned in the previous in the previous slide that there is a central repository which is the mvnrepository.com in this case, right? So, there may be multiple public repositories. So, if maybe that one particular jar file is available, dependency is available in another repository and it is not available in this MVN repository. So, that can also be prioritized. Like if it is not available, check in MVN repository. If it's not
No,
available,
Maven is the Maven repository. If you're using a Maven build tool, then it has to be there in the Maven repository. If it is not there, then you can push those so whosoever is the owner of that particular libraries which you wish to use, you can ask them to push their libraries to this particular central repository.
so
But there could be a use case like, for example, you are building some jar files for your project, and that is specific to your project, and you don't want to make it public, correct? So that could be a one case. So in that case, like, the way I just showed you, so you can have your organization's internal Maven repository, which is a general use case in many of the big organizations. So you can just create your own library and push it to the remote repository, so that other people who want to use this library, they can pull it from the your internals repository, your organization's internal repository.
yeah, and can there be multiple central repositories? That was what my question
No,
was.
it is all like, managed and maintained by the Maven itself. So you
it
can't.
will be always mvnrepository.com is a
Yes,
central
yes, it will be always a Maven repository in case of a Maven build tool, because it has a particular structure, and they are managing it. So the third party, it is not good from the security perspective also, because Maven might have some checks which are pre-applied as soon as you upload something to their repository. But if you download from the third party repository, then those security procedures, or like, those commitments can't be there. So that is basically giving a invite to hackers or malicious users, basically. Okay, so these are the certain Maven examples. So I have just tried to set up it on my EC2 instance. Okay, so I have just done the git clone, and I have this code here. Okay, so this is the structure which Maven will generally create. So you will have a main and you have a test folder. Inside the main you will have a Java, and then you can have a com or org depending upon the structure, and then you will have a your main package followed by sub packages, those kind of things. Like, at the end you might have your application file. So if you are aware like how Java packages are created or how they are packaged, then this would give you an example. Okay, so let's go to the top level, and here we have a POM file, and this POM file we have to run. So I think in meanwhile we have missed one slide, which is a Maven build life cycle, which tells basic what you can say goals. So main of the mostly used goals are the install, test, compile, and clean. So other are there deploy and validate and prepare resources, packages. They might be used in some cases, but generally the compile, install, these are the or in some cases test, these are the main goals. On some of the cases these all can be clubbed together when we I will just show you an example. So if we just go by definitions of the main, so compile is compilation. It does the source code compilation. Okay, then test is testing your code. So if you have some suitable test frameworks integrated, for example JUnit, then with like when you write Maven, test, then it will trigger your test framework. Okay, package generally, like if you want some jar file or war file to be packaged, like your binaries to be packaged into jar or war file, you can package them using this particular what you can say phase or goal. Okay, so you just need to mention in the POM. For example, the example which I showed you that had a jar as a packaging thing. Okay, then install is basically the step where you install your package or you install your artifact in your local or remote repository. So what happens when your whole package is generated or created, you want to push it into your local repository. Okay, for example, the example which you were saying, like when you create it, you want to install it into your local repository or into your remote repository or your central repository. So this Maven install can be useful in that case, so that your library is pushed into your local repository, so that other where, like if you want to use that library, that can be used. Okay, and deploying is also there. So I have not used it or not have not seen many people using it for deploying. So generally people, they use other mechanisms to deploy. Okay, so I have not set up the Maven hub, but let's see without setting if we can use Apache bin Maven. Okay, so return. Okay. So first is the compile. Okay. So if you see here, now it has started downloading the dependencies from the central repository. Okay, so these will get downloaded and installed into your local repository. So let it complete and then I will show you. First time it will download all the dependencies into your local repository, but next time when you run this compile, so it will check if those dependencies are there in your local repository. In that case, it will not download from central repository. If you add some new repository or if you change some version of your local so for your library, so in that case it will try to download from the central repository. Okay, so if you see this example, this sample code which I have shown you, so here there is a no dependency, but though there is a no folder called libraries, so you don't have to push any library into your code repository. Okay, so these all are downloaded on the during the compilation project. Okay, so if I just show you now the my home folder. So we have a M2 folder. Okay, inside the repository we have these different packages which are downloaded. Code, find bugs. So here if you see, then we have a POM file, because it is only downloaded the POM file because these could have been the what you can say dependent libraries which will get downloaded only when, well, these are just like for placeholder. Probably this is not a good example to show. Just simplest example could be the common HTTP client. Okay, common HTTP is in common So if you see here, so this is the basically the jar file which has been downloaded from your central repository into your local repository, and this library will be used during our compilation part. So if you see, go to our project. So this is where our binaries would be generated. Okay, so but it has just only been compiled because we have not packaged yet. So what we can do now, we can just try to do a package. Okay, so now if you see, it will download some plugins. Okay, and some more tool chains for compiling it. Okay, so it's failed probably this example. Okay, so they are basically some test fields. Okay, so let me just do one thing. For now, let's skip the test. Okay, so spelling skip test. Sorry, minus t skip test. I just don't remember the command. So what will happen, like, when we are packaging, so it should generate a tar file or jar file. So if we just go inside the target, so here we can see this is the our jar file. So it is the basically, if you see, the this is a version which we had given, and it is the artifact ID. Okay, so in this particular example, if you just want to run the unit test case, for example, okay, so we can also give this test option. Okay, but I think there are some test failures, so probably test will not run. So if you see here, test run 0, failure 0. So there is some issue with the test scenario, so that's why it did not run. So so example which I just showed, we can also run or skip some test cases. Okay, so this is how you can package it, and you can deploy. So now last part is how to install it. So we can install this particular package. So this package will now be installed into our local repository. So let me be skip test. Okay, so if this I will just show you now what happens. Like last step, installed our artifact or this jar file into this particular folder basically. Okay, so I will just show you. So here if you see, we have our jar files here. So if somebody else wants to use this jar file, so or even your code also wants to use this jar files, it can use it. So this is
So phase and goal are the same.
which one?
Phase and goal.
Correct. So these are phases are the life cycle phases. So they are just same as goals. So it's just a matter of saying it. Some people call it a phase when you say it from the build life cycle, or when you say it Maven goals when you want to execute those commands. Okay. So this is all I had for Maven. So now come to the second part. So any questions till now before we jump to the other topic? Okay, fine. So now let's start.
One question I had, like in the Maven install command that you had shown, so it got installed in the local repository. Now if you
Yes.
want to install it directly to the remote repository, then there is some location that we need to specify with MV and install.
Yes. Then you have to pass the argument where you have to tell where is your repository.
Okay.
So you can explore it. I think it is just like by default it installs into your home directory. But if you just provide the path, then it will install into that your repository. It could be your